Hi everyone, welcome. Today I'm going to introduce you the math behind Theta sketch. Actually, I'm going to introduce you the math behind KMV, K meaning value sketch. And the Theta sketch is a practical evolution of KMV. So, as long as you know the KMV, you will know how Theta sketch is working. We will explore its fundamental concepts step by step, and it will cover order statistics, case smallest estimation, KMV, and more. Please do not be intimidated by their fancy math terms. Actually, the idea behind them are quite straightforward. I believe we will just need elementary school level math to know the concepts. So, without further ado, let's dive in. What is order statistics? Let's say we have a 0 to 1 interval and we wanted to evenly divide it into two parts. We know we will only need one node and the value of the node will be 1/2. Same, if we want to divide it 0 to 1 into three parts, so we will only need two nodes and the value of the first node will be 1/3 and the second will be 2/3. And if we want to divide it into four parts, we will only need three nodes, and the first value will be 1/4, second value will be 2/4, and the third value will be 3/4. And we can rewrite these numbers into another way, like 1 divided by 2 can be rewritten into 1 divided by 1 plus 1. And 1 divided by 3 can be rewritten to the 2 plus 1 and can be rewritten into 2 divided by 2 plus 1. Same, 1 divided by 3 plus 1, 2 divided by 3 plus 1, 3 divided by 3 plus 1. What does this mean? In the first scenario, we know there's one node, and the index of the first node is 1. In the second scenario, we know there are two nodes, and the index of the first node is 1. Same, we have two nodes, and the index of the second node is 2. Same, 3 nodes, index equals 1, 3 nodes, index equals 2, 3 nodes, index equals 3. What is this? We can generalize a formula into this one. What does this mean? It means the estimated the value of case number equals k divided by n plus 1. That is order statistics. Quite straightforward, right? And it's been proved by the beta distribution. But the concept of the beta distribution is beyond our scope. Feel free to explore beta distribution yourself. So this equation or formula will help us to know that if we know the index of a node and we know the total number of the nodes, so we will know the value of these nodes. This will leading us to know if we know the index of this node and if we know the value of this node, we might know the how many total nodes in this whole sessions. This is leading us to the case smallest estimation. So we have this order statistics equations. The estimated value of case number equals k divided by n plus 1. And we want to rewrite or we want to rename this chunk to be like one symbol, right? We can write to any symbol, but in this case, probably we will just name it as theta. So we have these two formulas, two equations, and we can rewrite these equations into theta equals k divided by n plus 1. And after that, we can use our elementary school math to rewrite these equations. And we can multiply n plus 1 on both sides, and we can eliminate n plus 1 on the right, from the right. So yeah, after that, we can multiply 1 divided by theta on both sides, and we can eliminate this one. So it will give us n plus 1 equals k divided by theta. and we can uh, minus we can add -1 on both sides. After that, we will know like n equals k divided by theta equals 1. This is the k-smallest estimation, which means like as long as we know the index and the theta, we will know how many nodes in the whole interval or how many nodes in the whole sessions. Let me give you an example. So in this case, we have a 0 to 1 interval, and the first value is 1/3. Second value is 2/3. We know it, right? And what does this mean? The index is index k equals 1, and the theta is 1/3. So we will know the n equals k divided by k divided theta minus 1. So we will know that we have 2 nodes in the whole sessions. Same, the index of second number is 2, and the theta is 2/3. So we are using this second nodes also will know the total number n in the whole session is equals 2. This is the fundamental idea of k-minimum value or theta sketch. And the k-minimum value or theta sketch is trying to use a containers or sketch to implement the ideas of k-smallest estimation. So we want to build a data structure which could implement the ideas of the k-smallest estimation. That is the KMV, k-minimum value sketch. So in order to implement this idea into the real life scenario, we will need 2 requirements. The first one is we will need a uniform hash function, which means like this hash function can hash a string or other values into a float number, and this number should be uniformly distributed across the 0 to 1 interval, and the hash value should be independent to each other's. Second requirement is that we need a large enough sample size, which means as long as the sample size large enough, we can assume those values they are evenly distributed across the 0 to 1. After we have these 2 requirements, we can use the k divided by theta minus 1 formula to guess how many total nodes in our data structure. So the k minimum value sketch is the implementation of previous idea. And the beauty of KMV is that we don't need to store all the data. We only need to store the k numbers or k values in our sketch. And we can use these k values to estimate how many total numbers in our whole sketch. And the step is we can initialize the theta equals 1, and when there's more values into the sketch, we can update the theta. And as the theta becomes smaller, so we are guessing the estimated number of the total nodes are increasing. Let's use an example to show how it's working. Let's define a sketch with k equals 10, and we are going to insert 50 nodes into this sketch. As you can see, right? At the beginning, we'll initialize theta equals 1, and when the set size smaller than k, we'll just response the how many nodes, or when the theta equals 1, we'll just response the how many nodes in our sketch. So in this case, 3 and 3, they are going to exactly the same. But after there's more nodes inserted into the sketch, or the theta equals 1. No, theta is not equals 1. We are going to update the theta. So when the theta updated, the estimating we are going to estimate the size of the sketch. So we will know in this case there's total 19 nodes in our sketch, and we are guessing using k-smallest estimation guess now we have k equals 10 and theta equals 0.45. So we are guessing there's like 21 nodes in our sketch, but actually there are 19. Let's use more examples to illustrate how it's working. I feel like you might already notice that one, right? We only need the nodes from 0 to theta, and actually all those nodes larger than theta will be discussed or ignored in our theta sketch. So we'll only use this amount of data to guess to how many total nodes in our whole sketch. And the theta value, the theta is just the value of the largest value in this case smallest elements. So in this case we have total 40 nodes, but we are guessing, oh yeah, the number is good. We are guessing there are 40 nodes in our sketch. So all these nodes in here larger than theta, it will be ignored. They will not be inserted into the sketch. Actually, it will just be ignored. So finally, the total nodes we know, right? We have already inserted 50 nodes into our sketch, but we are guessing there's total 41 nodes in our sketch. So it is a probabilistic data structure, and it will guess how many nodes in our sketch and only use part of the node. I feel like I've been talked a lot. Let's see it again without my interruption. I can speed it up. So it will only use the case numbers to estimate how many numbers in the total sketch. And all those numbers bigger than theta will not save into the sketch at all. That is the beauty of the probabilistic model to estimate the whole numbers in a set. Much how KMV is working. Personally, I feel like it is beautiful. And for next one, let's go to the set operations. How KMV handle the set operations. I think there's a lot of probabilistic model in the market, like HLL, hyperlog, or bitmap, or Bloom filters. Why theta sketch is different compared to other sketches? Is like KMV sketch support full set operations, which means union, intersection, and A not B operations. I'm going to use two sketches to illustrate how set operation works. So they're going to have the same K, 25K, and the first size and the first sketch, they're going to container, or they're going to insert 60 items into the first sketch. In the second item or second sketch, we are going to insert 80 items into that sketch. So let's say we have two sketch A and sketch B. And in sketch A, we have inserted 60 items into the sketch. And in the sketch B, we have already inserted 80 items into the sketch. And the estimated number or the estimated hash sketch size of the first one is K divided by theta minus 1. And the case, both K in two sketch are 25, but the first theta in sketch A is 0.425. So we are guessing there are like 57 nodes in sketch A. And second one in sketch B, and this theta is like 0.22, 0.28. So we are guessing there are total 88 nodes in the sketch B. For the union operation, so we're going to find all the items smaller than sketch A. No, we are going to find all the items from sketch A and all the items from sketch B. After that, we're going to sort them. After sort, we're going to get the first k items into the new sketch, and the theta will be the maximum numbers of the first k items. After that, we can use the estimated numbers or functions to guess how many nodes in our whole united sketch. Let's use an example to do it. We're going to build a new sketch, and at first we are going to read all the data or insert all the thetas, all the items from theta A into new sketch. And we're going to insert all the items from theta B into the new sketch. After that, we'll sort them and select the first k items. The theta will be the maximum number of the first k items. So from 0 to theta, it will be the new sketch, and all the values bigger than theta will not be stored into the new sketch, and the estimated numbers of the new sketch will be 25 divided by 195 minus 1, so it's like 127. So we are guessing after union they're going to have the 127 items in our new sketch. And for intersection operations, the steps going to, at first we are going to compare the theta from theta A and theta B and find this smaller theta between them. In this case is 0.28. After that, we are going to read all the items from theta A smaller than like 0.28, and third step, we're going to read all the items smaller theta 0.28 from sketch B, insert to the new sketch. Let's use an example to do it. A new sketch, and compare the theta between 0.22 and 0.42, 2842. Yeah, and so this is going to be a smaller theta. Third step, we are going to read all the items from theta A which have the value smaller than new theta, and all the items from sketch B smaller than new theta. After that, we are doing intersect between these two sets. As we can see, there's like 5 nodes. 1, 2, 3, 4, 5 intersection nodes in this new sketch, and we are guessing how many total intersections in the whole interval, in the whole sessions. We are using we are using intersection nodes and divided by theta. So 5 divided by 0.28 is equals 17.86. So in this session, there's 5 intersection nodes, and we are guessing, based on this, we are guessing there are totally 17 nodes, like different in the whole sessions. And the difference operation or A not B operation is similar to intersection. We are build a new theta or new sketch, and we'll find the smaller theta between two of them. After that, we are reading all the items smaller than new Thetas from sketch A. We'll read all the items from sketch B which value smaller than new Theta. After that, we're doing difference operations. So in this case, we know there are 10 nodes in Theta A, but not in the Theta B. So in this session, we know there's 10 nodes difference. And so we can use the 10 divided by 0.28 to guess there's totally how many nodes difference in the whole sessions, which means 10 divided by 0.28 is 35.70 nodes. So we are guessing there's total like 35.70 nodes difference in the whole sessions. That is the set operations from the Datasketch or KMV. Actually, that is why the Datasketch is different compared to hyperlog-log. Because in hyperlog-log, you can only do union operations, but the Datasketch can do like all full set operations support unions, intersection, and difference operation. So finally, we're going to talk about Datasketch. Like we know, Datasketch is a practical evolution of KMV. So I'm not going to telling the implement details of Datasketch. Instead, I'm going to show the difference between KMV and the Datasketch. So after that, I believe you will know like what is Datasketch and what is Datasketch different from the KMV. At first, in the classical KMV implementations or ideas, the KMV will store the float type of numbers, which means numbers between 0 and 1. But in Sketch and in Datasketch, there's no need to save store the float type of numbers. Instead, the Datasketch install the big integers, long type of integers into the sketch. And so the theta, which leading the theta difference. When you are using the theta in the KMV, you can just use the theta. But when you're using the theta in Datasketch, you have to use the hash divided by maximum number of big integers, or hash divided by max numbers of the long dot max. After that, the estimating method will be same, k divided by theta minus 1. Both of them are same, but how they store the values and how they read theta is different. In KMV, you can just store the theta, but in the Datasketch, when you're using theta, you have to in time or real time compute the theta. Yeah. And another things in KMV, there's fixed k operation. There's fixed k, but in the Datasketch, like you are not a fixed k, and the Datasketch will handle the k by itself. So it's adaptive k, which leading the full set operations kind of different. Both KMV and Datasketch support full set operation, but if you want to use the k minimum value sketch, like they required like two sketch must have the same k, but since the Datasketch support adaptive k, so there's no need like two sketch have the same k set. And for the implementation, as our instinct, right, we can use the priority queue to install the smallest k numbers into the sketch or into the data structure. But in the implementation of Datasketch, it is not using priority queue or heap to behind the sketch. Actually, it just like contain array or list or array of numbers in the sketch. When the Datasketch trying to save into the disk or save into the I/O or do set operations, the Datasketch just use a quick select sort to find the first k items out of the array. So in this case, there's the insert method will be much faster compared to classical KMV implementation, because the KMV implement method will use the n log n times to insert items into the KMV. But the insert operation in Datasketches 01 is right away, and the only downside is when the Datasketch trying to insert is like trying to save the sketch into the IOs or set operations, it just do a quick select sort, only select first k items. Yeah, I feel like it's a smart move from the Datasketch. Yeah, which make it like much faster in the insert operations, and kind of like okay performance when the Datasketch trying to get the first k items. And also the Datasketch supports the confidence support. So when you're debugging Datasketch, this Datasketch will respond a lot of informations to help you know like whether your k is underset or do you want to bump up the k. Yeah, I think like that's pretty much all I have, and thanks for listening or thanks for watching.